The malware didn't begin with code. It began with credibility. The company didn't need to be real. It needed to be plausible for one interview cycle. A working website, a few LinkedIn profiles, and a role that sounded like the kind of remote crypto job people already see every week. That was enough to keep the conversation moving. And in this campaign, keeping the conversation moving was the point. The victim didn't have to ignore every red flag. They only had to explain them away. A call moved to text. A camera didn't work. A repository changed platforms. Then came the request that mattered. Clone the code and run it locally. None of those things proves an attack by itself. Together, they created the opening. This is the fake interview. I'm Valhax from Red Asgard. Episode 2, The Repository That Called Home. Before the repository arrived, there had to be a company. Not necessarily a real company, a believable one. Most people don't begin an interview like an investigation. They do what seems reasonable. Search the company name, open the website, check LinkedIn, skim the team page, and ask whether the opportunity fits the market. That is not laziness. That is how people survive the volume of remote work. You cannot run a full due diligence process on every recruiter message, every contract lead, every founder who says they need someone to review a prototype before Friday. Most of the time, people triage. Does the company exist? Does the role make sense? Does the person contacting me look connected to the market? Is the compensation plausible? Is the task something a company like this would actually ask for? If the answers are close enough, the conversation continues. That is the first useful word here. Close. The campaign did not need perfect legitimacy. It needed enough legitimacy to keep the victim from stopping. In remote software work, especially in crypto and Web3, the bar for weird is already high. Startups disappear, domains change, calls break, founders use half-finished websites and products that are still private. A company can have a polished pitch deck and a barely working backend. A recruiter can be real and still be disorganized. A startup can raise money and still have a broken interview process. None of that is good, but none of it is rare enough to end the conversation every time. That is the space the campaign lived in. Not certainty, but ambiguity. There's another layer to this. LinkedIn is supposed to be the trust layer. The operators treated it as inventory. A profile with a real face, a real connection graph, and a normal employment history can make a fake approach feel legitimate. But a profile can be stolen, purchased, rented, built slowly, or used by someone who doesn't understand where it will end up. A target checks LinkedIn and sees a person. The operator sees infrastructure. That matters because a fake recruiter does not have to convince everyone. They only need enough surface area to reach the people who are already open to opportunity. Freelancers, developers between contracts, Web3 engineers used to remote teams, people who see new projects every week and know that some of them are messy. The operators understood the market they were abusing. They knew that remote hiring already depends on weak signals. A website, a profile, a mutual connection, a plausible role, a repository with enough structure to look like software work. None of those signals is proof, but together they can move someone from curiosity to cooperation. The fake company didn't need to pass a full investigation. It needed to survive long enough for the technical task to arrive. Because the technical task was where the interview stopped being an interview. It became an execution environment. This episode follows a known pattern of DPRK-linked fake interview activity, often tracked under the contagious interview umbrella. The point here isn't to relitigate attribution in every paragraph. It's to show how the technique works when the job market itself becomes the delivery mechanism. The interview doesn't need to be dramatic. It's stronger when it feels ordinary. A recruiter reaches out, the role sounds plausible. The first conversation has friction, but not enough to kill the process. Maybe the camera fails. Maybe the first call becomes text only. Maybe the second call has audio, but no video. That's suspicious. It's also common enough that people keep going. People explain friction away because the alternative is expensive. If every broken calendar invite, every bad microphone, every missing camera, and every rushed founder call ends the process, you miss real opportunities too. The campaign hides inside that trade-off. The attacker does not need the victim to be careless. The attacker needs the victim to behave like someone who has seen enough messy startups to know that weird does not always mean hostile. Then the technical step arrives. Clone the repository, install the dependencies, run the app, share your screen. We'll walk through it together. To a developer, that sounds like work. To the operator, it's the moment the victim moves from conversation to execution. This is the part that makes the fake interview different from ordinary phishing. A phishing email usually tries to pull the victim toward a website, a login page, or an attachment. The fake interview uses the victim's own professional habits. It asks them to do what they already do: clone code, install packages, run local services, debug broken projects, and explain what they see. The request is not alien. It is familiar. That familiarity is the weapon. The attacker doesn't need to break into the machine from the outside. The attacker persuades the developer to run the attack from the inside. It turns professional cooperation into code execution. And once the developer has accepted that frame, the operator does not need to rush. They can let the victim do the setup. They can watch for errors. They can nudge the process forward. They can make the malicious step feel like part of debugging. If something fails, that does not necessarily break the illusion. It can strengthen it. A broken install is normal. A missing dependency is normal. A local service that needs one more command is normal. A developer sharing a screen while fixing someone else's project is normal. The attack is built out of normal. That is why it is dangerous. A developer opening a repository isn't supposed to feel like a security event. Modern development tools blur the line between reading code and running code. A package install can run scripts. An editor can trust a workspace. A local setup command can start more than the app the developer expects. None of that is inherently malicious. It's how modern software work functions. The campaign used that normality. The victim thinks they're evaluating a project. The repository is evaluating the victim. That is the inversion at the center of the episode. A real coding task is supposed to measure the developer. Can they read unfamiliar code? Can they reason through a broken setup? Can they explain architecture? Can they find the bug? Can they work with a team under pressure? The malicious coding task measures something else. What machine is this running on? Is this a developer workstation or a sandbox? Which browser profile is present? Are there wallet extensions? Are there SSH keys? Are there cloud sessions, package tokens, or source control credentials? Is this a machine with access to something worth stealing? The repository wants the real workstation, not a clean sandbox. A clean sandbox is less useful because it has less history. No saved sessions, no production credentials, no wallet extensions connected to actual funds, no source control access that belongs to the developer's real work. The operator wants the machine where the developer lives professionally. the browser profile with saved sessions, the SSH keys, the wallet extensions, the credentials that make the machine useful for actual work. The same things that make the machine useful to the developer make it valuable to the operator. The target isn't only the person, it's the person's normal working environment. That is why advice like, just inspect the code first, is incomplete. Inspection matters, but modern JavaScript projects are large, noisy, and dependency heavy. A malicious project does not need to place every bad action in the line the developer happens to read. It can hide in setup, in indirection, in dependency behavior, in code that looks like glue. A malicious repository does not have to look like a bomb. It can look like a bad startup repo. And developers are used to bad startup repos. They are used to broken instructions, missing environment variables, dependency mismatches, abandoned branches, and build steps that only work on the founder's machine. So the campaign takes advantage of a professional reflex. Keep going until it runs. That reflex is useful in real engineering. In a fake interview, it becomes an attack path. The repository didn't need to contain everything. If it did, it would be easier to analyze, easier to hash, easier to block, and easier to burn. A smaller design is harder to pin down. A small piece runs first, reaches outward, and asks for instructions. If the operator wants to change infrastructure, they don't need to rebuild the entire lure. They change what the loader retrieves. That's where the case stopped looking like one suspicious repository and started looking like infrastructure. There was a remote system waiting for the call. There were campaign identifiers, staged payloads, and signs that the operators expected parts of the system to be disrupted and replaced. One malicious repository is a scam. A repository that calls home to a staged delivery system is a campaign. That distinction matters. A scam can be opportunistic. A campaign has memory. It has replacement parts. It has routing. It has identifiers that let operators separate one wave from another. It has a way to change what happens next without rebuilding the first thing the victim sees. The repository is just the visible edge. Behind it is the system that answers. And once you have a system that answers, you have a defender problem. The defender is not only asking, what did this repository do? They are asking, what could it have retrieved yesterday? What will it retrieve tomorrow? How many other repositories call the same system? How many victims are already sorted into the operator's backend? That is where the investigation changes shape. At first, you are looking at code. Then you are looking at infrastructure. And infrastructure tells a different kind of story. It tells you whether the operator expected scale. It tells you whether the operator planned for disruption. It tells you whether the repository was a one-off lure or the front end of something larger. In this case, the answer was larger. The repository called home. Something was there to answer. A command server is useful until defenders find it. Then the operator has a problem. If the malware has one server address hard-coded, defenders can block it. If instructions live in an account on a public service, that account can be reported. If a paste disappears, the malware loses one of its fallback channels. That doesn't end the operation. It forces the operation to adapt. Earlier in the investigation, the campaign used public paste accounts as dead drops. A dead drop is a mailbox. The malware checks it for updated instructions without talking directly to the operator's server first. That gives the attacker flexibility. It also gives defenders something to remove. Think of it as a layer between the infected machine and the operator. Instead of the malware having to know the final destination forever, it can check a public location for the next instruction. If defenders take down one location, the operator can move to another. If a server burns, the instructions can point somewhere else. That architecture is useful because it separates the lure from the live backend. The repository can stay small. The first stage code can stay simple. The part that changes can live somewhere else. But public services have owners. Paste accounts can be reported. Abuse teams can suspend them. URLs can return nothing. The mailbox can disappear. That creates pressure on the operator. Not enough pressure to stop the campaign, but enough to make the operator improve the design. So the next version moved the mailbox somewhere harder to take down. The blockchain. In the next sample, the malware did something that looked normal in a Web3 project. It queried Polygon. Polygon is a blockchain. For a legitimate crypto application, talking to a blockchain isn't strange. Web3 applications talk to blockchains constantly. That's how they work. That gave the operators their cover. The payload wasn't only sitting on a normal server. It was stored in smart contracts. A smart contract is a small program deployed to a blockchain. Like other programs, it can hold data. In this case, the malware read data back out of those contracts, joined the pieces together, and executed what came back. From the victim's point of view, they were running a crypto project. From the malware's point of view, the blockchain was a payload delivery layer. That changed the defender's problem. A paste account can be suspended, a server can be seized, a domain can be blocked. A smart contract deployed to a public blockchain doesn't disappear because a hosting provider receives an abuse report. You can block access to the blockchain provider, but then you may also break legitimate Web3 work. That is the trade-off the operators were exploiting. They were not using the blockchain because the victim's wallet was the only target. They were using it because blockchain access already belonged inside the story. A crypto project talking to Polygon does not look out of place. A developer running a Web3 app expects RPC calls. They expect contracts. They expect the application to fetch data from chain. The operator hides the malicious behavior inside that expectation. That is why this evolution matters. The operators weren't only changing payloads. They were changing where takedown pressure could be applied. They moved part of the delivery system from infrastructure that can be removed to infrastructure that is designed not to be removed easily. That does not make the attack unstoppable. It makes the defender's choices more expensive. Block the provider, and you may break legitimate work. Allow the traffic, and malicious code can hide inside the same pattern legitimate applications use every day. That is the uncomfortable part for Web3 security. The same architecture that makes decentralized systems resilient can also make malicious delivery more resilient. In this campaign, the blockchain was not a symbol. It was infrastructure. For companies, the exposure path is indirect, which makes it easy to underestimate. The attacker may never touch your perimeter. They target a developer. That developer might be a contractor or someone using the same browser profile for freelance work and company access. Their laptop may hold source control tokens, cloud sessions, or private registry credentials. Now the company is in the blast radius of an interview it didn't know existed. That is the part many organizations miss. The company does not see the recruiter message. It does not see the fake interview. It does not approve the coding task. It may never know that a developer ran a repository from a stranger on the same machine where work credentials live. But if that machine holds access, The company is involved, whether it knows it or not. This is why developer security cannot be treated as only a laptop hardening problem. Developer endpoint security is supply chain security. It is identity security. It is cloud security. It is source code security. The fake interview is the front door. The blast radius begins after the door opens, and the blast radius does not stop at the person who took the call. It can reach a client repository, a package registry, a deployment pipeline, a cloud console, a wallet, a production database, a private Slack workspace. Anything the developer's machine can reach becomes part of the operator's opportunity surface. That does not mean every fake interview becomes a breach of every company connected to the victim. It means the access model is wrong if we pretend the interview is personal and the risk is personal. For developers, the machine is often the bridge between personal opportunity and organizational access. The campaign understood that bridge. That is why the target selection matters. They were not only targeting people who could write code, they were targeting people whose machines were likely to hold keys. The practical lesson is simple. Unknown interview code belongs in a hostile environment until it earns trust. That does not mean every recruiter is fake. It does not mean every startup is malicious. It does not mean every broken camera is an indicator of compromise. It means the environment has to match the risk. If the company is unknown, the recruiter is unverified, the call has strange friction, and the task requires local execution, do not run it on the workstation where your real credentials live. Use a disposable virtual machine. Use a separate browser profile. Keep wallet extensions out of the environment. Do not mount SSH keys. Do not expose cloud credentials. Read package scripts before installing dependencies. Review workspace configuration before trusting the editor. None of this has to be dramatic. It is just friction. And friction is what the attacker is trying to remove. The operator wants the process to feel normal enough that the victim keeps moving. The defender's job is not to panic at every weird signal. The defender's job is to notice when the signals cluster. Voice-only calls, rushed setup, broken cameras, repository migrations, a refusal to demo the project on their own machine, pressure to run the code live. One of those can be explainable. A cluster of them is a reason to slow down. Not proof, a reason to slow down. That is enough. Because this campaign did not need the victim to make one absurd decision. It needed the victim to make a series of reasonable decisions without stopping to ask why all of them were pointing in the same direction. Run the code. That was the destination. Everything before it was the path. And in the version that moved to Polygon, the final lesson is not only about malicious repositories. It is about where attackers place the parts defenders need to remove. In this campaign, the blockchain wasn't the target. It was the mailbox. This was the fake interview. I'm Volhax. Stay skeptical, and don't run strangers' code on your real machine. See you next time.